Good morning, 8th grade. Today I'm going to be filming module 4.6, and this one is piecewise and step functions. So we're going to learn about these two different types of functions. Step function is like a piecewise function, but we are going to look at our learning target. I can identify and graph piecewise defined functions, and then I can identify and graph step functions. So let's look at what a piecewise graph or piecewise function or defined function looks like. Okay, I'm just going to just make something quick. And let's say this is my coordinate plane, and then if I have a graph which looks something here this way, and then I have, let me just do it with a different color so you can see better. I just closed the blinds. I think that made the glare a little better. So yeah, so if I have a graph which is like this, and then I might have another graph which is something like this. This is what a piecewise defined function graph looks like. And this graph has different rules for different intervals, as you can see, and for different intervals of its domain. Once again, domain is my input or my x, and my range is the output or the y. Okay, so once again, these functions, some of the functions cannot be described by a single expression because they are defined differently depending on the interval of x. And these functions are piecewise defined functions, and a piecewise linear function has a graph that is composed of some number of linear pieces. So let us create a graph based on some of the information that I have. So this question that I've just written out, this is an example of a piecewise function, piecewise defined function. So I have graph f of x is equal to, I have 2x plus 4 if x is less than 1, and negative x plus 3 if x is greater than 1. And then we are going to state the domain and the range. Okay, so in these functions, what I need to do is I need to solve each different expression that is provided to me. And that means I'm going to have two different tables. I'm going to have one table for the top, and I'm going to have one table for the bottom that is given to me. And then I'm going to have both those pieces of information in my same graph. So let's go ahead and look at the top one. What does this say? It says f of x is equal to 2x plus 4 if x is less than equal to 1. So I'm going to create one table for the top one, which is f of x. Okay, it's saying f of x is equal to, what is that? 2x plus 4 if x is less than equal to 1. So this is going to be one table, and then I am going to have another table, which is this one. And this tells me that f of x is equal to negative x plus 3 if x is greater than 1. So I am going to go ahead and create a table for each of these, and then I am going to graph it. So for this one, we are going to say what is x and what is y, or x and f of x. So if I have a table drawn out for this one, And I'm just going to say x, and we know that f of x is what? F of x is y. So I am going to give values over here, and it's saying that x is less than and it's equal to 1. So what is equal to 1 is 1. What is less than 1? 0, -1, -2, -3. These are the values which are where it's saying x is less than or equal to 1. And then it's saying that y or f of x is going to be a solution to this. So when I do 2 times 1 to x plus 4, I'm just substituting the values into this x over here. Look, this. So when I say 2 times 1 is 2 plus 4 is going to give me 6. Okay? And now I substitute for x, I say 0. So 2 times 0 is 0 because anything times 0 is 0. Plus 4 is going to give me 4. -1 times 2, positive times negative, is going to give me negative. So that gives me my -2 plus 4 is going to give me 2. Opposite signs then, because we subtract the absolute values, give the sign of the bigger number. All right. Then -2 times -2 is going to give me -4 plus 4 gives me 0. And then the last one I have -3. So -3 times 2 is -6 plus 4 gives me -2. So here are my ordered pairs of the first graph. Let's go ahead and do the second one. So I'm just going to make both the tables first. Let me go ahead and do this one. So this one, I'm just going to do this side so I have a room in the middle for the graph. Okay, so here we go. We have my x and we have my y. Okay, and now what is it saying? It is saying graph f of x is equal to -x plus 3 if x is greater than 1. So we are going to start with 1 and we'll talk about that in a minute as to why. Okay, so we go 1, 2 and greater than 1. So let me take just 5 values, 3, 4 and 5. And then it's saying -x plus 1. So plus 3, sorry. So here we're just going to substitute the values. -1 plus 3 is going to give me 2. -2 plus 3 is going to give me 1. -3 plus 3 is going to give me 0. And the same way, -4 plus 3 gives me -1. -5 plus 3 gives me -2. So here are my ordered pairs for my second equation that is provided, the second function. And now what I'm going to do is I am going to go ahead and graph this. So let me create my coordinate graphing system. So now that I've created this, I'm going to go ahead and graph each of these values. Let's look at the first ordered pair. And we know that x is less than or equal to 1. So what's the maximum, what is the ordered pair I'm getting over there? Is 1, 6. So I know that we are going to place a dot at 1, 6 to indicate that the endpoint is included in the graph. And why is it included? Because it's saying less than or equal to 1. So if you remember when we did inequalities in 6th grade and we talked about the open circle, closed circle, that's basically what this is. An open circle means that it is not included. Closed circle means that that value is also included and everything less than that, right? So same concept over here. So since it's saying less than equal to 1, we have the ordered pair is 1, 6. So I'm going to use green to show you this one. This is 1, 6. I'm going to go all the way up here. And look, it's going to be a closed circle. Okay? And here is my ordered pair for 1, 6. And then I am going to plot all the other points. So this one is my closed circle. Okay? And I have 0, 4. So 0, 4. So these are my ordered pairs. Okay? Then I have negative 1, 2. I have negative 2, 0. And I have negative 3, negative 2. Okay, so once I have this drawn out, remember that I am not the best at drawing over here where it's not already, equally spaced out, but that's fine. We are looking at what we are doing. Okay, and so then we are going to plot the points and we are going to draw the graph beginning at 1, 6. So once again, we have over here, as you can see, we have 1, 6, 0, 4, negative 1, 2, negative 2, 0, negative 3, negative 2. And then look, from here, we are going to take this line like this. And here is my graph for the top part. Okay, so here we go. Now, let me use, and this one is closed, okay, because it negative 1 is included because less than equal to, so that is why that's a closed circle, completely closed. Okay, now let's look at the second one. Okay, in the second one, what is it saying? That it is x is greater than 1. Now, if it's greater than 1, is your 1 included? No, it's not included. So that is why we are going to have an open circle for this part of the graph. So let's look at our value. So again, because x is greater than but not equal to 1, we are going to place a circle at 1, 2. So at 1, 2, we are going to have here a circle. That's an open circle. And then we are going to go ahead and we are going to plot all the others. And so we have 2, 1. Okay, so 2, 1. So here is my, okay, and then I have 3, 0, which is here. Then I have 4, negative 1, which is here. And I have 5, negative 2. 5, negative 2. Okay, so then once I have this, once again, I am going to go ahead, I am going to connect those dots. And here is my other function rule that I have over here that is provided. And so what do we see about the domain and the range over here? Okay, so let's look at, we can talk about what is the domain and what is the range. Okay, so once again, domain is my x and range is my f of x, which is y. Okay, so let's go ahead and look at this. Domain is going to be what? All real numbers. Okay, so domain is my all real numbers. And then what is my range? Now that's the one that's affected. Range is, we look at what is the highest point in the graph over here. And the highest point is up here. So that's what my range is. So it's going to be my y values are going to equal what? Everything which is less than equal to 6. So range is the one that, because normally the domain, of course, it's all real numbers, and the range is what we are looking at based on what is the highest point, or we could also have a graph going this way and then we can talk about what the range in that is going to be. But this is what a piecewise defined function is. Okay? So let's go ahead and look at another example really quick. And now I have given you a graph f of x is equal to where x minus 4, x is greater than 1. And I have the second equation, which is negative 2x plus 3, where x is less than equal to 1. So I am going to go ahead and create a table for each of these equations. And so the first one, fx is equal to x minus 4, and x is greater than 1. So what is greater than 1? We have 2, 3, 4, etc. But we are going to add 1 because I know that if it's greater, I am going to have an open circle over there, right? So let's just say 1, 2, 3. Okay, I'm going to give those values. And then if I am saying 1 minus 4, I get negative 3. 2 minus 4, negative 2. 3 minus 4, I get negative 1. So these are my x, y values, my input and my output, or x and f of x. And these are my ordered pairs that I'm going to be graphing. So let me go ahead and graph the first one. And in this, what do I have? I have, what kind of a circle is this going to be? Because it is greater. So therefore, I am going to have an open circle. And so I have 1, negative 3. So 1, and I have negative 3 over here. And so I'm just going to, again, I'm going to graph an open circle over here. There we go. That's telling me that, 1 is not included. Okay, because x is greater than 1. And then I have 2, negative 2. I have 2, negative 2. I have 3, negative 1. Wait, this is not done properly. Here we go. 2, negative 2. 3, negative 1. It would be going this way. Okay, and so here is my graph for that one. Okay, and then let's do this one with saying fx is equal to negative 2x plus 3, x is less than equal to 1. So obviously what is equal to 1 is going to be 1. What is less than 1 is 0. And we can do negative 1. So I'm just giving these three values right now. And so let's look at this. 1 times negative 2 gives me negative 2 plus 3. And I am going to get 1. 0 times, so negative 2 times 0 is 0. Plus 3 is going to give me 3. Negative 1 over here, my value of x. So negative 2 times negative 1 is going to give me positive 2. Okay, so negative 2 times negative 1 gives me 2 because negative times negative is positive, plus my 3, and I'm going to get 5 over here. So now these are my ordered pairs. Now let's look at this one. And I'm going to use the color red. It's saying less than equal to 1. So that means 1 is included, and so this is going to be a closed circle for me. Okay, it's going to be a dot at 1, 1. So over here, this is going to be a closed circle. Okay, then I have 0, 3. Here's my point. I have negative 1 and 5. Here's my point. And then all I do is from here, I am going to go ahead and draw my line. Apologize, it's not the straightest from that direction. Let me try it from here. Okay, all right, so here is my line. Okay, now let's look at the range, the domain and the range. Okay, so domain, as we can see, my x, it is going to be all real numbers. Okay, domain is all real numbers. And let's talk about what is a range over here. So if I'm looking over here, what is my lowest point on the graph? Because I know that from there on we are going upwards, right? So if I am looking at this, I can see this is my lowest point and everything else is above that, right? So I can say range is y is greater than -3. So that's what a piecewise defined function is. So the next thing I want to talk to you about is a step function. And a step function, the parent function for a step function looks like this. F of x is equal to these fancy brackets, which look like they have double line kind of a thing, of x. So what this basically means, as soon as I see this, I should automatically know that whatever number I'm getting, I need to round down. I need to round down. Normally, we are used to always rounding up. And, in the sense that if we say 5/10, then we round to the next value, which is 1. But when I look at this notation over here, the parent function f of x is equal to these fancy brackets with the x inside, then I know that we are going to round down whatever values are given to the integer below it, okay? So let's go ahead and look at what a step function is, okay? So step function is a type of piecewise linear function with a graph of horizontal line segments. And one example of step functions is the greatest integer function, and written as I just told you, and this is nothing but the parent function of the greatest integer function, okay? And in which f of x is the greatest integer less than or equal to x. And so once again, I have drawn it out for you. I've drawn out the graph of the parent function over here. And this is a type of graph. It has disjointed line segments. And the graph of a step function is a series of disconnected or horizontal line segments, as you can see. And domain is all real numbers because the dots and the circles. Look, this is the circle, this is the dot. This is the circle, this is the dot. Here's the circle dot, circle dot, circle dot. And that's what we mean. Okay? And so because the dots and circles overlap, the domain is all real numbers. And then range is all integers because the function represents the greatest integer less than or equal to x. The range is all integers. So in this, normally we take decimal values also. Let's say I say 1 and 5/10, 1 and 9/10, 1 and 25/100. It doesn't matter what decimal values I take, it's going to round down to 1. Okay, so that is why you are rounding down to the integer below, and that is why our range is all integers. So let's go ahead and do a problem or two so that we understand what step functions are. So we are going to go ahead and graph f of x is equal to, within the fancy brackets, x plus 1. Okay, and that's telling me that this is a step function. Okay, now as soon as I see the x plus 1, we've already done module 4.4 where we did all the transformations with translations and your stretch and whether the graph is going to be compressed or is being stretched, what is going on, whether it's vertical, horizontal, and also we talked about reflections. So just using that, remember I have created it really in depth in module 4.4 if you want to pull up that concept again. But if I'm seeing x plus 1, what does that tell me? It's grouped together inside. So I know that I have to take this graph and it is going to shift because it's plus 1. It is going to shift. I said it's the opposite, right? So instead of the right, this graph is moving to the left because it's saying x plus 1. And how much is it moving to the left? 1 to the left. So we have already done the parent function of f of x is equal to, x in this case, which is here. All right, and in this, what did we see earlier? That we have those open and closed circle. It starts from 0 to 1, and then from 1 to 2, and then 2 to 3. So if I'm saying it is moving 1 to the left, guess what? Everything is going to move, not here, is going to move to -1. And that's basically, just by looking at that, I know. But let's see how to solve this. Okay, so what I'm going to go ahead and do, I am going to start with some negative values, and then I'll go to positive. So I am going to start with -2, but I'm also going to give myself a few values that are between the integers. So we know that the integers are like the whole numbers, -2, -3, and then on the other side 0, 1, 2, 3, 4, right? So, but I am going to give myself some decimals also over here. So if I say -1 and 7500, I can say -1 and 5/10, -1 and 2500. So let me go ahead and give myself these values, okay? Yes. And then let me go ahead and give values such as, we're going to have -1, and then we have our -5/10. We can have -2500. So I'm giving some decimal values also. And then let me also select some which are positive. Okay, so let's say 0 and 2500, and let me say 5/10, 1, and then let me say 1 and 7500, 1 and 2500. I can give all of these, okay, so I can carry on. So let me make one more column, and here I'm going to say 1 and 7500. So I've given all these values over here. And then I am going to go ahead and I am going to solve all of these really quick, where I am doing what happens when it's x plus 1. Okay, so I get over here, I get -2 plus 1 gives me -1, right? Then this is going to be -7500, because 1 and 7500, -1 and 7500 plus 1, -1 and 5/10 plus 1 is going to give me -5/10, -2500. Okay, then in this case I'm going to have 0, because -1 plus 1, and then I am going to have again here your -5/10 plus 1, so I'm going to get 5/10 over here. Then I'm going to get 7500, right? And so basically I'm just substituting the value. I'm saying x plus 1. And then I get 0 plus 1 is 1. And I have 2500, that's going to be 1 and 2500. 1 and 5/10, and then I have my 1 plus 1 gives me 2, 2 and 2500, 2 and 7500, etc. So now I have given myself certain decimal values also, and I have included the integers. Okay, so the points to look at, I know, are going to be my the integer values. So I can see I have, well, let me go ahead. This over here, okay, there are no fractional parts. This over here, there are no fractional parts. Here, there are no fractional parts, no fractional parts. Okay, if you can see what I have just circled. And so now if I am rounding, because this is what I need to do. What this means is I am going to round it to the value which is less than that. So for the first one, x plus 1, yeah, I get, what do I get? I get -1. Okay, and then what about -7500, -5/10, -2500? Okay, so all of these, look, if they are on the number line, they are over here. Okay, so on the left, when I'm rounding down, it's the number which is, you know, to the left on the number line. So you're rounding down. So all of these are actually going to round to nothing but -1. We round down. Okay, for this one, it is 0. Let's look at all these. We have 5/10, so 5/10 is here, 7500 is here on the graph. So rounding down means to the integer below, which is what? 0. So we are literally rounding down. That's all we are doing. Over here, it is 1. Now, let's look at 1 and 2500, which is here, and look at 1 and 5/10, which is here. What is the integer before that? Is 1. So all of these are rounding down to 1. Okay? And then over here, I already have 2. And then look at this one. This is 2 and 2500 is here, and 2 and 7500 is here, closer to the 3, but we have to round down. And what is down? Which is 2. So everything is being rounded down to the integer below. And that's basically what this is, because all of those values are going to fall from this integer to this integer. Okay? So now when I am, so let's look at this once again, what I just said. So -1, okay, -7500, -5/10, -2500. So look at those 4 values. These are greater than or equal to -1, but less than 0. So since -1 is the greatest integer that is not greater than -1, -7500, or -2500. So basically what's happening, you're just rounding down to that integer. Okay, so now let's go ahead and we are going to graph this. On the graph, dots represent included points. Circle represent points that are not included. So we did say the domain is what? All real numbers. And we said the range is all integers. So domain is all real numbers and the range is all integers. Once again, what is the domain? Is the x. What is the range? Is the y, which is the f of x. So if I am graphing this, and we did say that it has shifted 1. So earlier it was starting here and going this way. Now, because it has shifted 1 to the, because +1 means the graph has shifted to the left 1, right? So as you can see, what are my ordered pairs? I can just go ahead and take these because everything is rounding over there. So I have -2, -1. Okay, so if I am doing my graph, here's my -2, which is a closed circle, and -1 is an open circle. Okay, that's an open circle. Here, open circle. There we go. And then we continue with this, and then we have -1, 0. So -1 is going to be my closed circle here, and 0 is my open circle. So this is closed and that is open. And then now we can see that is going up in the step. We have 0 and we have 1. Okay, so we have 0, 1, and so we know that 0, 1 is here, and this is what I'm graphing. Okay, and here is my closed circle, and here is my open circle. Then I have 1, 2. Okay, so 1 and 2, so here's my closed circle and here is my open circle. So looking at this, we can continue building this graph. On 3, I will have my closed circle, and then here I have my open circle, and closed circle, and open circle, and closed, and open. And so then it carries on like this, and same thing down. Okay, so between those integer values. And so we can see over here, the same thing here. I'm going to bring this is open, and this is closed, and open, and closed. Okay, and then open, and here. So that's what a graph of the step functions looks like. And once again, a domain is all real numbers. And then we know, as we talked over here, look what happened. The entire graph from here, it has shifted 1 to the left. Everything has shifted 1 to the left. It's translated to the left, because we have the x plus 1 grouped together. And so when I know when it's plus, it's going to move to the left 1. If this was x plus 3, what would it have been? It would have moved 3 to the left. If it was x minus 4, then it would have moved to the right 4 units. Okay? So that's basically what this means. So we just graphed the f of x, what was it, plus 1, right? And this is the graph that I got with that one, the step function graph. This one is f of x, x plus 1. Okay, so let's go ahead and do another one, and I'm going to leave this graph so that you can compare. This was plus. Now this is saying minus 4, x minus 4. So we know that they are grouped together. So I know that it's going to be shifting. And so when I'm saying minus, we talked about what? X minus 4 means it's going to go in the reverse direction of what we normally think. So that means this graph is going to go 4 units to the right. It's going to translate 4 units to the right. So let's quickly put some values just to confirm what I'm talking about. So once again, I've taken negative values, I've taken positive values, and I have put those decimals in the middle so that we can see where we are rounding down. And so if I do x minus 4, I am going to get a negative 1 minus 4, I get negative 5. Okay, and so I keep doing the calculation. Negative 5/10 minus 4, and I get negative 4 and 5/10, negative 4 and 25/100. So this is basically, you're just subtracting 4. So 0 minus 4 is negative 4. And then I have 5/10. So minus 4, this gives me negative 3 and 5/10, negative 3 and 25/100. And then I get 1 minus 4, I get negative 3. 1 and 25/100 minus 4, I get negative 2 and 75/100. And then I get negative 2 and 5/10, negative 2 and 5/10. So these are the values that I am getting. Okay, now once I've done that, I am going to round down. Okay, so if I look at negative 5, of course this is the one which is fine, the ones which are already giving me the integer values. This, I have this, I have this. Okay, so here I can already automatically go and see I have to put, I get negative 5, I get negative 4, I get negative 3. Right? Now, let's look at these values. So I have negative 4 and 5/10 on the graph over here. Okay, what's the integer to the left, because I am rounding down to the smaller number? It is negative 5. So all of these are rounding to negative 5. Let's look at negative 3 and 5/10 is over here. What is the integer below? It is negative 4. So all of these are rounding to negative 4. Okay, and then I have negative 2 and 75/100, and which is over here, and I have negative 2 and 5/10, which is here. The integer below is negative 3. So these are all rounding to negative 3. Okay, so if I start graphing this onto my graph over here, this is what the step function is going to look like. Okay, so I will go to 1 and negative 3, and let me just start from there. So I have 1 and negative 3. So we have closed and open. Okay, and here's open, and then we have closed. Okay, and then we have open, and then we have closed, and we have open, and closed, and open, and then we can go backwards. Okay, here's open, and this is closed. All right, so look, 0, negative 4, and then I have over here, this is open, and this is closed. Okay, so now let's look at this. And okay, and we keep continuing, and I just do for here, I go here, and open, and closed, and open. All right, so let's look at this graph compared to this graph. And this one is f of x is equal to fancy brackets, right? And we said x minus 4. So compare this one. In x plus 1, it translated 1 unit to the left. So look, there's the graph, because this is my parent function. Parent function graph, it starts here. It has gone 4 units, it's translated 4 units to the right because it's minus, so it's going to go that much to the right. And so I just wanted you to see both the graphs on the same coordinate system in order to be able to compare. So once again, if it's saying plus something, is going to the left that much. If it's saying minus, it's going to the right that much. And so we just graphed it, and you can see the reason why. But this one here, this is my graph of fx is equal to x minus 4. Okay? And this is basically what my step functions are. So let's do one last problem with a vertical change. And I can see over here, why is this a vertical change? Because in the other two, what did I do? My grouping was inside. It was x plus 1. So that the x plus 1 had to be done first. Or the x minus 4 had to be done first. Right? So that's why that was horizontal. In this case, my x is inside, but then look what I have outside. I have this, so it's telling me that it's being vertically, it is moving. Okay, now I can also see it's negative. That means my slope is going to be negative. Okay, so let's go ahead and solve this. And now my function is graph f of x is equal to negative 3 of this, x over here, and we are trying to do the step functions. So if I have negative 1, we know this is negative 1, right? And then I can see that over here, all of these are being rounded down. If I'm writing this, that means I'm rounding down. And so this is -1, this is 0. And then I know that 5/10 is rounding to 0, 75/100 is rounding to 0, right? And then I have a 1, and 1 in 25/100 will round to 1, and 1 in 5/10 will round down to 1. And then after that, I am doing -3 of this. So -3 times -1, this gives me 3, 3, 3. And -3 times 0, all of these are going to give me 0. And then -3 times 1, all of this is -3. Okay, so I am going to go ahead and look at, okay, my ordered pairs, which would be this, and I'm looking at the integer values, and here are my ordered pairs. Okay, so let me use a different color, then we can see all the changes that are going on in the 3 different types of graphs that I have over here. Okay, so if I say 0, 0, and let me go ahead and start plotting. I have 1, -3, and then I have my -1, 3. Okay, so I have -1, 3. So here's -1 and here's 3. So here's my graph now, closed and open. Here we have now 0 and, okay, and then we have our 1, okay, we have 1 and we have -3, which is here, 1 and -3, which is again here. Okay, and so when I carry on, look at this one. What is happening? The graph is moving. How is it moving? We can see that it is vertically, obviously it's a negative slope. And so look at the gaps over here. It's not just 1, 1, 1 anymore. So it is 1, 2, 3, right? Next will be 1, 2, 3. This is open. And this will be closed. Okay, in this case it will be 1, 2, 3, and this will be closed and this is open. So look how it moved, because again, what kind of a translation is this one? This is going to be a vertical one. So you can see more gaps between them. In the others, there is, it's just a shift. Okay, whether it is to the left or to the right. So I wanted to show you all of them on the same graph so that you could see this, the green one over here. This one is f of x is equal to -3 of x, like this. And so that's the green one. And I know that negative is telling me it's a downward slope. And then 3 is how much it is moving vertically. Okay, so that's basically what step functions are. Once again, piecewise functions. You are going to have 2 different equations. You are going to create 2 different tables. And then you are going to plot it on the same coordinate system. You are going to have an open or a closed circle, depending on if it is less than equal to, or just less than or greater than. And then you're going to list out your domain and range. So let's look at this one. In this case, my domain, of course, again, in the green one, my domain, of course, is all real numbers. And in the range, what do I have? I have integers, which are all multiples of 3, because it's moving in 3, okay? So once again, so you will just list for your piecewise and for your step functions. Remember, step functions, it gives some decimal values also, but basically what are we doing? When you see that notation, all you're doing is rounding down. and then they are these horizontal, they look like stairs literally when you are graphing it, and that is why it's called step functions. And this concludes our module 4.6. Have a great day, everyone.